Hi and welcome to my channel. My name is Tobias and today we're going to look at a proof of the solution formulas for quadratic equation. So our task for today is to isolate x in the equation a times x squared plus b times x plus c equals 0. The goal of the proof is to show that if d, the discriminant, is less than 0, we have got no roots. If d is equal to 0, we have got one root, which can be calculated with this formula, x equal to minus b over 2 times a, and a, b, and c can be calculated or looked up at this equation here. And if d is greater than 0, we've got two roots which can be calculated with the following two formulas. The one root can be calculated by minus b plus the square root of d over 2 times a, and the second root can be calculated by minus b minus the square root of d over 2 times a. For the proof, we've got some good ideas. So first off, we want to multiply with 4a on both sides of the equation. So we start with this equation up here, and we do some stuff to it to get to this x and get these formulas down here. So we firstly multiply by 4a, then we add the discriminant, which is equal to, or d, which is equal to b squared minus 4 times a times c, on both sides. So we add this on both sides, and then we look at this expression here, and we just look at what that is equal to down in the proof. So now we go to the proof, and we start with this normal quadratic equation. Then we multiply, so this is one of our good ideas, we multiply by 4a on all terms on both sides. So all terms are going to be multiplied by 4a. So 4a times ax squared plus 4 times bx plus 4a times c. So on all these terms, and 4a times 0, because we have to do it on the right side too of the equation. We have to do it on all terms. A times a is equal to a squared. So this term would become this term. And here we get 4 times a times b times x, we just get this term. And 4 times a times c, we just get this term. And 4 times a times 0 is equal to 0. When we multiply by 0, we just get 0. And now we go to the second good idea. We add the discriminant on both sides. So on the left side, we just add our discriminant, and we do the same on the right side. And I've just color-coded this to see that we have added it on both sides of the equation. And now if we look at this step, we can see that it says plus 4 times a times c, and we've got minus 4 times a times c. So these two terms will disappear, and we're left with the first term, the second term, and the fourth term. We just write them up, and we just take this, which is equal to d, and we write d instead of all of this, which will make it easier for us to calculate and look at this equation. Now we just take a step back and we just look at what this parentheses squared is equal to. So now we have got some expression up here on the left side, and we want to do something about it. So we just look at this parentheses, which is also a good idea, and we inside this expression inside 2ax plus b is squared. So we have to say this first term squared plus this term squared plus 2 times the first term times the second term inside the parentheses. So we get this. And if we have this expression inside parentheses and it is squared, we have to do it on both the number and the letters. So 2 squared is 4, a squared is a squared, x squared is x squared, b squared is just b squared, and 2 times 2 is equal to 4 times a times x times b. So we get this. And fortunately, this is equal to this expression up here on the left side. And if this expression is equal to this expression up here on the left side can be substituted by this expression, because this was equal to this. And if expressions are equal to each other, then we can just take one out and put the other in instead. So we substitute this by our parentheses now, and we continue with the proof. So we take this on the left side and substitute it by this parentheses squared. And still we've got d on the right side of the equal sign. We want to isolate x, and to do that it's a bit difficult when this parenthesis is squared. The inverse function of squared is a square root. So we take the square root on both sides of the equation, and we just have to look one moment up here. A and b are going to be some numbers in our equation up here. X are going to be our variable, and it's going to be maybe some numbers. And if we look at this parentheses, when we square numbers, if this is going to be, if we put in a value for x, and this is going to be equal, all of this inside the parentheses is going to be equal to a negative number, then we square the negative number, and minus times minus equals plus. The same can we say about a positive number. So if we put in an x value and all of this inside the parentheses is going to be a positive number, then a positive number multiplied by itself is going to give us a positive number. So this equation could never be true if d is a negative number. So if we put in some values for x and d is going to be negative, this equation will never be true, because this is going to give us 0 or a positive number, and that could never be equal to a negative number. So we can at this point say that if d is negative, we've got no roots, no solutions to this equation. Our next step is to say that this could both be a negative and a positive number, and when we square it, we get a positive number. So when we take the square root on both sides, we have to make sure that on the right side we put in a plus and a minus sign, because it could be both a positive and a negative number on the right side, or in this parentheses up here. So when we leave all of this out, we have to make sure that this was the case once, so we need to put in a plus and a minus sign. Now it's going to be easy, because now we have all the big parts out of this proof. Now we just have to subtract b on both sides. So when we do that, we get 2ax equals minus b plus minus the square root of d. To get our x, we just have to divide by 2a on both sides. So we divide by 2a on both sides. 2a divided by 2a is going to give us just x left on the left side. So x is now isolated, and we've got this right side minus b plus minus the square root of d over 2 times a. So to sum up, if d was less than 0, we have got no roots. We have got no x's that would make this equation up here true. So if our discriminant is less than 0, we've got no roots, no solutions to our equation. If d is equal to 0, we've got one root, and that one root can be calculated by this formula. Just look at this formula and put in a 0 on d's place up here, and we can see plus minus the square root of 0. That just gives us 0. So it's going to end up with minus b over 2a. So this is our formula for for the occasion that d is equal to 0. And if d is greater than 0, we've got two roots, which can be calculated with the two formulas down here. This formula up here would have to be two formulas because we've got a plus and a minus sign. So we've got the one root is going to be calculated by minus b plus the square root of d over 2 times a, and the other root is going to be minus b minus the square root of d over 2 times a. In which order you do these two roots is not important at all. You can do this one first, use this formula, and then this. You don't have to use it in this, but normally you would take the plus and then the minus, but yeah, that's up to you. So that was a proof for the solution formulas for our quadratic equation. So thanks for watching. See you next time. Bye bye.